What's up, everybody? And it's been 2 years, but we're back with another video. Today we're doing MooTube, the USACO 2018 January contest silver. So essentially this problem is about MooTube, which is kind of like YouTube, but like for cows. But there's N videos, numbered 1 to N, and there's also this metric of relevance, which Farmer John has already calculated the relevance of n minus 1 pairs of videos, and conveniently they connect like every one of the videos. So in your mind, you should be picturing like a tree, because we have n minus 1 edges and n nodes. Um, and another thing is that you can actually calculate the relevance between any two arbitrary videos. You just need to find the minimum relevance of any connection along the path. Okay. And then there's also this kind of like K value, so that any given video, all other videos with relevance at least K will be suggested, right? So the question is actually in the form of a bunch of queries, and each query has two numbers. Each query has two numbers, the K and the V. So the K value and also the video that it's targeting. So it's essentially saying if I set my K value to this, how many videos are going to be suggested when I watch the video V. Okay, so hopefully this will make more sense as I bring up the whiteboard. Okay, so as you can see in this example over here, I have the videos as a tree over here. Each node is going to represent a video, and each edge is essentially like the relevance between two videos. So in my particular example, I have k equals 4 and v equals 6. So my v equals 6 refers to this video right here. That's our starting point, and we're trying to find every other video with a relevance of 4 or greater. Okay, so let's go. So let's look at this 3 over here. It's directly connected to 6, so and the relevance is exactly 4, so that's greater than or equal to 4. So I think this is one of our choices. And so I'm just going to mark it like this. Not like this. We also have this one over here, which is 5. So if you go along this path, it's 4 and then 5. So the minimum of 4 and 5 is 4. 4 is greater than or equal to 4. So yes, this one is also one of the relevant videos. Let's see here. 1, it is 4 and 6. So that's minimum is 4. 4, 6, 5. This one works. 4, 6, 5, 1. That's not gonna work because the minimum of 4, 6, 5, 1 is gonna be 1, which is less than 4. So this is not 5 is not one of our relevant videos that's gonna be suggested. So let's keep looking here. Yep, this works. And 3, nope, it's not gonna work. Okay, so we found every one of our videos, right? So this is 1, 2, 3, 4, 5. So the answer is 5. 5 videos are going to be suggested. Okay, so how do you solve this problem? Well, we can see here, right? Every single time we encounter something like a 1, so every single time we find like a 1, or we find like a 3, maybe like a 2, we simply cannot include those edges, because whenever we include those edges, the minimum has to be less than 4, right? Whenever we see an edge that's less than 4, if we include it, the minimum will be less than 4. So we just have to traverse the graph starting from the start node, which is v equals 6 in this case, so it's this one over here. We start over here, and then we traverse the graph using either BFS or DFS, but we can only enter the nodes where the relevant numbers, their edges, it has a weight of 4 or greater. So if it's less than 4, we just can't go there, because we know that if we go there, it's not going to work, because the minimum is going to be less than 4. Okay, so in this particular case, we already did this, but let's just try one more case here. Okay, so the next case is v equals 10 and k equals 4, right? So we are starting from this node over here, and then we're trying to get to other nodes, right? So we can start from here. We're going to look at its neighbors. We're going to see, okay, 5. We can see that the relevance is 6. That's greater than 4. Okay, yes, we can go there. So we can mark 5 as one of our suggested videos. And then we keep looking from 5. We can see that 2, we can see 9. But look, their relevance are both less than 4, right? So whenever we see that, we just can't go there. So, and we look for more neighbors of 5, but there are no more neighbors of 5. So we can actually stop right here. We look at more neighbors of 10. Well, there aren't any more neighbors of 10. So 5 is the only one that's suggested. So our answer is going to be 1. So the code is going to be pretty straightforward. I would say BFS and DFS both work. It doesn't really matter which one you choose. But all you have to do, the only modification is that, you know, if the relevance is less than your k, you just cannot go there. So you just have to do an extra if statement on top of that BFS or DFS, and you should have it figured out. So here we have our main function. We read in our file. We have read in our MooTube.in, MooTube.out, pretty standard. We get our n and q. So for each edge over here, I actually store it in a 2D array called adjacent, with a pair of ints. So the first one is going to be the video, and the second one is going to be the relevance. And so we do that for everything, and then we cycle through q times. For each q, obviously we have the k and the v that we see, and I also subtract these because I just want to do zero-based indexing. It doesn't matter if you don't. And then we just solve. And for the solve function over here, I have this q, double-ended q, because I think it's faster. We also have this visited. When we're starting from v, obviously we say our visited is true. I'm gonna set the answer to 0. Then, okay, so while the queue is non-empty, we go in, we get the current video we're looking at, and then we cycle through all of its neighbors. As you can see, the neighbor and the relevance is listed here. If the neighbor is not visited and the relevance is greater than or equal to k. So this is the important part. Only if those two conditions only if both of those conditions are satisfied, we're gonna go into this node. So that's just q push back the neighbor, and we set the visited to true, and we add 1 to the answer. And then at the end we return the answer, and here we just print it out, and that's pretty much it. So I would say this problem is one of the easier ones in the silver division. It's essentially just a BFS with a tiny modification. I think the main point that you need to see is kind of like the minimum relevance, and also with a relevance at least k. So those two pieces kind of tell you, kind of give you a lot of clues here. And also, well, you also have to know that it's a tree. But other than that, I think that's gonna do it for this problem. Let me know in the comments below if you want me to keep doing this kind of videos. I know I haven't been doing USACO problems for like 2 years, but hopefully I'm gonna make more videos in the future. Wait, I literally almost forgot the outro. Hopefully you guys enjoyed this video, and I'll see you in the next USACO problem.